Alright, so in this video we'll go over section 5.7, solving equations by factoring polynomials and problem solving. Alright, so let's begin with the principle of solving polynomial equations by factoring. So in essence, these are the steps that we follow. So every time we're given an equation, we need to have every single term, all terms, on the left hand side of the equation. I'm going to use a different color that actually looks better. And then from there, factor the left hand side. In this case, well, you may use every single technique that we have learned in the previous sections for factoring, such as the GCF. Okay, let's write them all. Like the easiest one, which is the GCF, maybe grouping, maybe a trinomial, and in this case there are two cases, double bubble, or diamond method. Right, then we also have differences of squares. Alright, so we have many methods to factor these polynomials. And then we're going to use a new property that we learned in this section, the zero product property, which states, well, once we have a polynomial into factors a times b equals 0, what we do is set every single factor equal to 0. The basic case is to have to factor, so each factor is being set equal to 0. Or if we can also extend this to many multiple, many multiple cases in which we can set equal to 0, not just 2. But well, if this symbol throws you off for a bit, well, this is what we can do. Let's do some examples. So examples A and B, in this case, they are giving us the equation already in factored form. So what are we going to do in this case? Well, in this case, we're just ready to use the zero product property. Okay, so I'm going to highlight each of the factors. I'm going to use blue for the first factor and orange on the second factor. So by the zero product property, either 3x plus 2 equals to 0 or 2x minus 1 equals to 0. That means factor in blue, set it equal to 0. Okay. And the factor in orange, set it equal to 0. Alright. And solve the baby equation, subtract 2 to both sides to get 3x equals to negative 2, and divide both sides by 3 to get x equals negative 2/3. So that's one solution. We're done with one. And then over here, add 1 to both sides to get 2x equals to 1, and divide by 2 on both sides to get x equals 1/2. So two solutions in this case. Two solutions. Let's look at letter B. Of course, we can extend this to multiple cases. So I'm going to highlight the first factor with blue, the second factor with orange, and then the third factor with I had pink. Okay, and that's all we do. Set the 2x equal to 0, x plus 5 equals to 0, and 3x minus 7 equal to 0. So in this case, this first equation, first baby equation, comes from the first factor. The second baby equation comes from the second factor. And the third equation comes from the third factor. So in this case, this one is very quick and easy to solve. Just divide both sides by 2. Boom, cancel the 2's. X equals 0 divided by 2, which is 0. Over here, only subtract 5 to both sides. Boom, they cancel. X equals -5. Second solution. And for the third one, well, we need to work a little bit more, but nothing impossible. Add 7 to both sides. Boom, boom, they cancel. 3x equals to 0 plus 7, which equals 7. And divide both sides by 3 to get x equals 7/3. Alright, and that's the solution to the first exercise. Alright, now let's look at more elaborate examples. Well, and by more elaborate examples, I mean examples in which they don't give us the polynomial in factor form. In this case, we need to apply all factoring techniques. So these examples are really nice, because they are just ready to do the zero product property. Now let's do some work over here. Okay, so 7x squared minus 13, and then in this case it's already set equal to 0. All right, so let's see. Number one, we need to factor this polynomial. Well, the first thing we always try is factoring out the GCF, and in this case the GCF is the lowest power of x, but between 7 and 13 they don't have anything in common, so this is x times 7x minus 13, and set that equal to 0. And in this case we're ready to just use the zero product property. So I'm going to highlight the first factor with blue and the second factor with orange. Alright, now we're going to use the zero product property, so the factor in blue, set it equal to 0, and then the factor in orange, set it equal to 0. So for the first factor, we don't really need to do anything, because this is already solved for us. X equals 0, no need to add or subtract anything. And then over here, add 13 to both sides to get 7x equals 13. And then divide both sides by 7 to divide this out, and then x equals 13 over 7. Okay, two solutions. Well, why are the two solutions? Well, because the degree of the equation is a second degree equation. And later we're going to move on to equations with more solution. I think it's going to be worth to write that down. So I'm going to go ahead, and in this case I'm going to circle these two, degree 2, two solutions. Alright, what about an equation like letter D? Well, number one, yeah, this equation is really messy. We need to have, number one, everything on one side of the equation, but first we need to clear the parentheses, and we get that by using the distributive property. Okay, so that's going to give us x times x, that's x squared minus 3x equals 88. And then I'm going to move this 88 to the left hand side of the equation by subtracting it on both sides. Over here, these two cancel on the left hand side, and on the right hand side they cancel, and then on the right hand side I'm going to get the following polynomial: x squared minus 3x minus 88 equals to 0. Okay, now we need to find a way to factor this polynomial. Well, if we go back to the different methods, notice that polynomial has 3 terms. That is a trinomial, and we can use the double bubble, and that is when the leading coefficient equals 1, or the diamond method when the different coefficient is not 1 and it cannot be factored out. So in this case, I think we're safe to use the double bubble method. So let's double bubble it. So x and x. So we look for factors of 88 that add up to -3. In this case, I'm thinking of -11 and plus 3 because 3 minus 11 is, wait a minute, not 3, it's 8 rather. 8 minus 11 is negative 3, and negative 11 times 8 is negative 88. So now that we have it in factor form, we're good to just do what we did in the previous page. Highlight if possible. Well, you don't have to highlight, but I do just so you can follow what am I doing and where is everything coming from. So we're just ready to apply the zero product property. Set each equal to 0. In this case, well, I'm going to use the same color coding here. So blue for the first factor and orange for the second factor. Okay, so I'm going to set, in this case, x minus 11 equal to 0 and x plus 8 equal to 0. And these equations are really baby to solve. All we need is to add 11 to both sides. Boom, cancel. X equals 11. Done. First solution. On the other hand, this x equals, all we need to subtract 8 on both sides. Cancel. X equals to negative 8. And we're done. Okay. So let's see. Oh, a very common mistake here is to think of this as the product property. You know, like let me do this with red, so we can take this as not to do. Don't. So in this case, it's going to be x times x minus 3 equals 11. Equals 88. So don't do this. X equals to 88 and x minus 3 equals 88, which equals x equals 91. If you look at this, these are not the same solutions as we had over here. So don't do this. Okay. This is called zero product property, and it's always work only when the right hand side is equal to 0 and everything else is on the left hand side. All right, let's look at another example. Well, we have a polynomial equation. However, we have this negative 12 on the right hand side. We need to have everything on the left hand side, and we can do that by just adding 12 to both sides. That's all we do to get 2x squared plus 11x plus 12 equals to 0. And in this case, we have another trinomial like the one we have in the previous example. However, the difference between these two is, in the previous one, we were able to use the double bubble method because the leading coefficient was 1. In this case, the leading coefficient is not 1, and on top of that, we cannot factor it out. So we can do some factoring with double bubble. So in this case, we will have to use the diamond method. So I'm going to multiply the leading 2 times 12, which is 24. And I'm going to bring down the middle coefficient, which is 11. Okay, so we are going to do the following. We're going to look for factors of 24 that add up to 11. On the one hand, I'm thinking of 6 times 4, that's 6 plus 4, that's 11. No, that's not going to work. And 12 times 2, well, 12 plus 2, that's 14. That's not going to work either. But I'm thinking of 8 and 3. All right, 8 and 3. And let's see, what do we do with these two numbers? 8x, 3x. Okay. So in this case, well, we're going to have the following: 2x squared plus 8x plus 3x plus 12 equal to 0. So we turn this polynomial into a 4-term polynomial in which we will use the factor by grouping method. So let me go over here. Okay, let me go So I need to find the GCF of the first group. What do they have in common? So the GCF is 2x, and then I'm going to be left with x plus 4. And then I'm going to factor the GCF on the second group. And if we look at these two terms, well, between 3 and 12, they have a 3 in common, x plus 2. And again, observe how these two are always the same. If you don't get these the same, well, then double check your calculations over here in the diamond or over here when we're writing the polynomial or the equation. So I'm going to factor out the x plus 4, actually, not 2. So x plus 4. Oh, don't forget to write equal to 0 because we're solving an equation. And then 2x plus 3. All right. So let's highlight the blue ones and the orange one. Okay, so in this case, I'm going to use this color coding for the zero product property. In this case, I'm going to go on this side and I'm going to set x plus 4 equals to 0 and 2x plus 3 equals to 0. And again, let me highlight with what I have here so you don't get lost on what am I doing. And this is, so subtract 4 to both sides. That's all we need to do here to cancel. So x equals to negative 4 and subtract 3. 2x equals to negative 3 and divide both sides by 2. X equals negative 3 halves. Alright. And those are the two solutions. Again, observe the degree. The degree is 2. Potentially, we may have up to 2 solutions. Alright. So let's see. For letter F, there's a silly typo here. I'm going to correct this part. This is not supposed to be a 71. This is supposed to be 17 instead. So let me change that and turn that into a 17, because otherwise the work we're about to do here is not going to work. So what are we going to do in a situation in an example like this? Well, first of all, observe the fraction. So what are we going to do here is to multiply both sides by the least common denominator, which in this case is 3, to get rid of those fractions. So let's distribute 3 times 2x squared. That's going to give me 6x squared equals, when we distribute the 3 on the first term of the right hand side, 3 times 17, whatever that number is, but divide by 3 rather, those 3's are going to get cancelled. So that's just going to give us 17x. And last but not least, 3 times 1, which equals to 3. Alright. So now the next step is again to have all terms on the left hand side. So I'm going to subtract 17x on both sides. And I'm going to subtract 3 on both sides. Okay. So these two divide out. Not divide out. These two cancel out. So I'm going to get the 0 on the right hand side. And on the left hand side, I will be left with 6x squared minus 17x minus 3. And set that equal to 0. Again, in this case, we have a trinomial. The leading coefficient is different than 1. We won't be able to just do double bubbles, because in this case, we cannot factor out that 6. So let's use the diamond method in this case. And I'm going to multiply 6 times negative 3. That's a negative 18. And bring down the middle coefficient, which is negative 17. Okay. So then from here, I'm going to look for factors of negative 18 that add up to negative 17. Well, 9 times 2 is 18, but negative 9 times 2 is not going to give me negative 17. So 6 times 3, that's 6 plus 3 is not going to give me any combination of 17. So in this case, I'm going to use 18 itself and 1. But in particular, I need the product to be a negative number and the sum to be a negative number as well. So to get that done, I need the negative to be the largest number. So this will be broken up into negative 18 x and 1x, which is simply x. All right, that's all we do. Alright, so let's move on to the next step. So I'm going to go up here and I'm going to write 6x squared minus 18x plus x, and then minus 3. And then because we have 4 terms, we're going to factor by grouping. Factor this by grouping. Group these 2, group these 2. So in this case, well, in the first group, we can see that between the numbers 6 and 18, their GCF is 6. And as far as the powers of x, the lowest power is 1, so 6x is the GCF, and I will be left with x minus 3. And over here, between x and negative 3, they don't have anything in common, x minus 3. However, in a case like this, which may be a little bit tricky in order for this not to throw you off, I'm going to put parentheses and I'm going to multiply by an imaginary one. Ultimately, 1 times whatever quantity is whatever quantity it is. Okay, so in this case, 1 times x minus 3 equals x minus 3. And the reason for which I put this additional parenthesis is so you don't feel a little bit weird about this. So we can identify the next GCF. Okay, set it equal to 0. So x minus 3 times 6x plus 1. And in this case, we have 2 factors to deal with. X minus 3 and 6x plus 1. So let's set each of them equal to 0. X minus 3 equals to 0 and 6x plus 1 equals to 0. On the one hand, we'll add 3 to both sides and subtract 1 from both sides for the second equation, then divide both sides by 6. So x equals to negative 1/6. So 2 solutions, again, degree 2, 2 solutions. All right. So let's move on to the next page and see what do we have in there. All right. So we have a very short equation. Looks short, but we need to be very, very careful here, because I know what you might be thinking. Well, let me do it first. Let me do it the correct way, and then I'm going to show you what not to do. All right. So again, if we follow the method, the first step of the method is to have all terms on the left-hand side of the equation. So I'm going to subtract 4x on both sides to get x cubed minus 4x. Now, number 1, in this case, the degree is 3. Potentially, we are going to have 3 solutions. Alright, so degree 3, 3 solutions. And don't forget to keep setting this equal to 0. So in this case, let's find a way to factor out this polynomial. Okay, so factor out the x. That's going to give us x squared minus 4 equals to 0. But in this case, well, we are done with the first step of the factoring. We need to do a second factoring because if you observe, x squared minus 4, right, that's nothing more than a difference of squares. That's a difference of squares, so in this case we need to factor this further as x plus 2 and x minus 2. Or minus 2 and plus 2, doesn't matter. And then from here, let's highlight our factors. X, which is going to be set equals to 0 there. Well, that's already our first solution. And then on the next one, x plus 2, set that equal to 0. And then subtract 2 to both sides to get x equals to negative 2. And then finally, we set x minus 2 equals to 0, add 2 to both sides. Cancel, cancel, and this goes with pink, this goes with pink. And x equals to 2. So 3 solutions. Okay, incorrect way to do it. Let me show you the wrong way to do it. Don't do the following. X cubed equals to 4x. What most people might be thinking of this is to divide both sides by x. And then cancel, cancel. Then x cubed over x gives us x squared equals to 4. And then when I move this 4 to the left hand side, I'm going to have this difference of squares, x plus 2, x minus 2. So in this case, from here, x equals to negative 2, and from here, x equals to 2, which is not wrong in the sense of the solutions that we obtain. But do you see that we have a third degree equation? From here, where is the third solution? Okay, where is that third solution? So by doing this, we miss that piece of information here. Okay, so when you do the homework on MyMathLab, if you do it this way, you will be presenting only 2 solutions. You put it on MyMathLab, it's going to mark it wrong. So that's why this is correct. All right, so this is the way. All right, that is the way in this case. All right, let's look at another example. Letter H. Well, this is most likely like the biggest one that we are going to do in this case. Well, first step again, move everything to the left hand side by subtracting x on both sides and by subtracting 5 on both sides. Cancel, 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 cancel. X cubed plus 5x squared minus x minus 5 equals to 0. So that's what we're going to be left with on the left hand side. Because we have 4 terms, that is correct. Factor by grouping. Factor by grouping. On the first group, in this case the lowest power of x that I can factor out is squared. And in the second group, notice the only thing they have in common is the negative signs. I'm going to factor out the negative 1, x plus 5. Negative 1 times x. Notice I'm writing it in this format so you can see the x plus 5 and x plus 5 in this format. So I'm going to factor that out. Okay, let me highlight this with blue so you can keep track of this guy. And that's going to give me x plus 5 times x squared minus 1. Don't forget the equal to 0, equal to 0. Okay, so in this case, let's see. We think we're done, but not exactly, not quite. Because just like the previous example, what do you see here? Another difference of squares. Alright, so we need to factor this a bit further. X plus 5 times x plus 1, x minus 1. Okay, and then from here, let's highlight every single factor. Blue, orange, and pink. X plus 5 equals to 0, x plus 1 equals to 0, x minus 1 equals to 0. And let's highlight each of them just so you can see where are each coming from. They come from the factoring we did in the previous step. And solve each baby equation. So add 5 to both sides, x equals to 5. Subtract 1 from both sides, x equals negative 1. Add 1 to both sides, x equals to 1. So 3 solutions. Notice 3 solutions because we have a degree 3. Alright. Okay, let's move on to the next page. So the next page is going to take us to some of the word problems. So some word problems that give rise to solving equations by factoring polynomials. So let's read this problem. And in this case, well, the shorter leg of a right triangle is 2 feet less than the other leg. Find the length of the 2 legs if the hypotenuse is 10 feet. Well, notice in this case they're telling us right triangle. Okay, so let's draw a right triangle. Notice the hypotenuse is 10 feet. And in this case, one leg is shorter than the other leg. Well, but we don't know the length of one of the legs. In this case, the largest. Let's call it x. The other one is 2 feet less. That means x minus 2. That's what 2 feet less than the other leg. But the other leg, that's our x, which in this case is this one. So what are we going to use in this case? In this case, well, there is a very powerful theorem that relates the sides of a right triangle and the length of the sides of a right triangle. In this case, we're going to use Pythagorean Theorem. Which in this case states that the first side square plus the second side square equals the hypotenuse squared. In this case, you might want to label this if you want. So call this A, call this B, and call this C. All right. Now let's put everything in the Pythagorean Theorem. Pythagorean Theorem formula. So A in this case is x, so that's going to be x squared plus the quantity B, which is going to get squared, x minus 2 squared equals the quantity C, which gets squared as well. That is 10 squared. All right, so let's see. Let's expand this binomial. Keep in mind that we don't just square these two guys. X squared plus x minus 2 times x minus 2 times itself, and all we do is FOIL again. 100 squared, that's the same as saying 10 squared is the same as 10 times itself, which equals 100. So FOIL, FOIL. So the first x squared, it's going to go here. Okay, the first x squared, and then we're going to go x times x, that's an x squared. X times negative 2, that's a negative 2x. Negative 2 times x, that's another negative 2x. And negative 2 times negative 2, that's going to give us a positive 4. And that equals 100. Alright, it looks like we have a lot of terms to combine. So 2 bars for the squares, 1 bar for the x's. So in this case, x squared plus x squared, let me go up here. That's going to take us to 2x squared, and then negative 2x minus 2x, that's a negative 4x. And then plus 4 equals 100. And again, the method to solving this equation is by having all terms on the left hand side. So we're going to subtract the 100 on both sides to make that a 0. So this 2x squared minus 4x, and 4 minus 100, that's a negative 96 equals to 100. So in this case, I know what you might be thinking, well, we have a trinomial whose leading coefficient is not 1, so you might want to use the diamond method, or that's what you think you will have to do. But in this case, it's not necessary to use the diamond method, because notice in this case we can divide out this coefficient, because 2, 4, and 96, they are both divisible by, they are all of them, the three of them are divisible by 2. So divide everything by 2. Well, on the right hand side, 0 over 2, that's the easiest one. Over here they cancel, giving us an x squared. And negative 4 over 2, that's a negative 2x. And negative 96 over 2, that's a negative 48. So in this case, this problem will reduce to a simpler double bubble problem. In this case, factors of negative 48 that add up to negative 2. Okay, so in this case, I'm thinking of 6 and 8. However, I want the sum to be a negative, so the largest has to be the negative, and the smallest the positive. Also, positive times a negative is negative. So solving the baby equation, x plus 6 equals 0, and x minus 4 equals to 0. So x equals negative 6, and x equals to 4. Alright, however, in this case, because we're looking for the length of a triangle, in this case the negative solution won't make sense. We are only going to make sense of the positive one. Alright, so there's no such thing as negative length. So it's not like you go to Home Depot, for example, and then you're telling the guy that you want to build a window, a triangular window whose length is negative 6 feet. Well, that guy's gonna look at you, and it's not gonna make sense out of it. All right, so we don't look for negative lengths, only positives. All right, now let's go back to our picture. Let's go back to the original problem, because the problem here is not to solve the equation, but actually to answer the question related to the word problem. So in this case, well, what are we going to do? So we're gonna go back and plug in x equals to 4, and x minus 2, which is 4 minus 2, which equals to 2. All right. So in this case, summarizing everything, leg 1, the shorter, well, just the longest rather, is 4 feet. All right. And leg 2, the shortest, is 2 feet less, which in this case 2 feet. All right, so that'll be the solution to this problem. And then we have another very classical problem in algebra in which they give us the function that describes the trajectory of a projectile, so something like it's gonna look roughly like this. You throw a projectile, right, and it's gonna go in this direction, it's gonna go up, and then it's gonna hit the ground, right? So we have an object that is being thrown with an initial velocity of 64 feet per second off the edge of a 960 foot cliff. The height h of t in feet of the object after t seconds is given by the function. Well, in this case, you can pretty much ignore everything. All we'll look at is the given function. So determine how long before the object strikes the ground. Well, so in this case, striking the ground means when the height is 0, all right? Because that's the height at the ground, 0 feet. In other words, in our mathematical terms, that's when h of t, the height, equals to 0. So I'm going to do the following. H of t equals to negative 16t squared plus 64t plus 960. And I'm going to use this property here when it hits the ground. This is a 0 equal to negative 16t squared plus 64t plus 960. Okay. And well, it might be a little bit weird to read an equation this way. Typically the 0 is on the right hand side and everything else is on the left. So all I'm going to do here is reverse the order so that doesn't confuse you with what we did earlier in the previous examples. So in this case, we're ready to solve this equation, and no, you don't want to do the diamond method on this because everything here is divisible by negative 16. Everything goes into negative 16 nicely. You might want to divide by the negative so the leading term becomes a positive term. So cancel, that's a t squared. 64 over 16, that's a positive or negative, that's a negative 4. And 960, divide that by 16, that's going to give us a negative 60. And in this case, we can just do the double bubble method. T and t. Factors of 60 that add up to negative 4. I'm going to think of 10 and 6. Minus 10 and plus 6, because 6 minus 10 is going to give us negative 4. 10 times negative 6 is also negative 60. If you do the other way around for the signs, you will have a positive 10 minus 6. That's not going to give us a negative 4 instead of positive. So in this case, t equals to 10, and in this case, t equals to negative 6. However, we are going to discard one of the solutions. We discard the negative signs because in this case, negative times, well, we cannot go, basically this is telling us to go back in time. All right, and well, it's not really possible to go back in time in this case, so we'll disregard this negative solution unless you're friends with Marty McFly or Doctor Who. That way you can travel in time, travel to the future, travel to the past. Well, but that's just science fiction. All right, so in this case, it's going to take 10 seconds. So the object that was thrown from this height to hit the ground. Alright, and this is the end of this video. I'll see you in the next one.